The next problem, problem number 2, is factor a trinomial of degree 2, and I have in parentheses the generic form ax squared plus bx plus c, even though that's degree 2 because that's the highest power of the variable x, where the leading coefficient a is not equal to 1. So I picked some random numbers for a, b, and c so that we'll be able to actually show the illustration of the factoring of this trinomial. Again, trinomial has 3 terms, so tri being the base of that, we're keeping that in mind. Now, suppose that a is 3, b is 13, and c is negative 10, so the trinomial will look like 3x squared plus 13x minus 10. The objective here to factor the trinomial is to essentially decompose the trinomial into a product of a set of binomials, which are going to be 2-termed expressions. Okay? So essentially we're trying to go from ax squared plus bx plus c. We're trying to convert from that to the following. Okay? Where in fact A1, C1, A2, and C2 are numbers such that when we remultiply the 2 binomials back together, we'll end up getting our original trinomial. So what that really means is that we're going to use what we call a FOIL method. The FOIL method would be really the way to check to see whether or not the decomposed structure for the trinomial that became the binomials multiplied together can be remultiplied together to give you back the original trinomial. So let's look at a model for the FOIL method. FOIL, F-O-I-L. FOIL stands for first, outer, inner, and last. So if we were to remultiply our binomials together, the 2 first terms would be a1x and a2x. We're going to multiply those together. So a1x times a2x, that should give us f. The O will be the outside terms. That's going to be the a1x times your c2. The inner term is going to be the c1 times the a2x. And then, of course, the last term is going to be the 2 last values, which is going to be c1 and c2. Those are going to be multiplied together. Then we're going to add up all of these terms that have been constructed through multiplication. All these terms should then become ax squared plus bx plus c. So that's our objective. Okay. Now, in dissecting and decomposing this trinomial, we need to make a set of parentheses. So we got, again, 3x squared plus 13x minus 10. We're going to decompose that into a set, 2 sets of parentheses. First of all, we're going to take 3x squared and we're going to decompose that into a product of 2 terms which remultiply together to give us 3x squared. Okay, so I'm going to pick 3x and then x. The next idea is that we want to multiply two integers together that will give you -10, such that when both of these binomials are multiplied together, we're going to come back to our original trinomial. Yes. Yes, sir. Got a question? Okay, go ahead. Okay, did everybody hear that? Let me just kind of repeat his question. Okay, he's asking that when we decompose the 3x squared into 3x and x, he's wondering, did it make any difference which order they came in, whether we put the 3x as the first term of the first binomial and the x as the first term of the second binomial, or whether we could say x for the first term of the first binomial and use 3x as the first term of the second binomial. No, it doesn't make any difference at this point, because in solving this, we're going to use trial and error, basically, to come up with the terms that work to make our multiplication process complete, okay, and accurate. So at this point, no, it's not going to make any difference. So we're perfectly legitimate to go with the 3x and the x, where I put